There's a network of observers stationed above your street right now, and you were never told about it. It has no headquarters, no budget, and no chain of command. Nobody staffs it, because it has never needed staffing. It has been running for longer than surveillance has existed as an idea, longer than cameras, longer than the written word. Its agents perch on power lines and rooftops and the bare branches of winter trees, and they have already decided what they think of you. That decision is not private. It gets shared. In 2024, researchers pointed one of the most capable animal communication AI systems ever built at hundreds of thousands of recorded bird calls, fully expecting to find nothing more than grunts of alarm and contentment. What came back instead forced a rewrite of what scientists thought they knew about the blackbirds that share every city on Earth. These were not random noises. They were, in some real sense, a running commentary on us. The research behind this starts in northern Spain, where a team from the University of León has spent years wiring up a population of carrion crows with microphones and biologgers, recording every sound the birds make across an ordinary day. The archive that resulted is staggering, something on the order of 150,000 distinct vocalizations. Almost none of it is the loud caw most people picture when they think of a crow. The overwhelming majority is quiet, low-volume murmuring, so faint it sat unanalyzed for decades simply because no research team had the bandwidth to sort through it by ear. That changed once the Earth Species Project, a nonprofit built specifically around applying machine learning to animal communication, joined the effort in 2024 and started running the recordings through a neural network trained to find structure in the noise. And it found structure, repeating patterns, consistent groupings, calls that clustered together in ways that were clearly not random. Some of those clusters line up with concrete, testable behavior, like the sounds crows seem to make specifically when returning to the nest with food. Here's the part worth being careful about, because this is exactly where the story tends to run ahead of the science online. The researchers have not announced that they cracked crow grammar, and they have not claimed the AI produced human names. What they have built, in their own description, is closer to an atlas, a map of which sounds exist, and when birds use them, a necessary first step before anyone can responsibly claim to know what a given call actually means. I'm telling you that up front because everything that follows is true and does not need embellishment to be remarkable. To see why any of this is even plausible, you have to unlearn 100 years of assumptions about bird brains. For most of the 20th century, the working theory in neuroscience was that real cognitive sophistication required a cerebral cortex, the layered, wrinkled tissue that mammals use for higher-order thought. Bird brains don't have one. They're smooth. And for a very long time, that smoothness was treated as a hard ceiling on what a bird could possibly be capable of. The problem with that theory is that evolution doesn't only have one blueprint for intelligence. Birds built something else entirely, a structure called the pallium, which bears no resemblance to a mammalian cortex on the outside, but does strikingly similar work on the inside. Pack a crow's skull with neurons at the density researchers have actually measured and scaled for body size, you land somewhere in the neighborhood of a chimpanzee. That is why corvid researchers have started calling crows and ravens feathered apes. And it is not a cute nickname, it is closer to an honest description. Brain imaging work has since shown exactly what fires. When a crow looks at a human face, it has previously filed under threat. Multiple regions light up together, including the structure that functions, in a crow's brain, the way the amygdala functions in ours, the seat of fear and threat processing. In other words, when a crow flags you as dangerous, it isn't pulling up a static image from storage. It's running something close to an actual fear response, memory and emotion firing, through the same overlapping circuit. The clearest demonstration of exactly how far this goes came out of Dr. John Marsloff's lab at the University of Washington, and it has become one of the most cited pieces of behavioral research on any bird. Marsloff wanted proof that crows could recognize specific human faces without turning any one member of his team into a permanent target. So the solution was a mask, one distinctive rubber mask, worn every time the team trapped, banded, and released wild crows on campus. Getting caught and banded is stressful for any bird, and the crows responded the way you'd expect, fighting the handling and calling out in distress. Then the mask came off, the researchers went back to their normal faces, and the trapping stopped. What happened next is the reason this study is still famous. Put the mask back on years later, and crows across campus would immediately mob and dive bomb whoever was wearing it, with zero regard for who was actually underneath. That alone would be impressive. What makes it extraordinary is who was doing the mobbing. Marsloff put the mask back on nearly 5 years after the original trapping, by which point most of the crows originally caught had already died of old age. The birds attacking him that day had, overwhelmingly, never personally encountered the mask before in their lives. They knew the face anyway. Somewhere along the line, adult crows had passed a specific threat, tied to a specific face, down to offspring who had no direct experience of it at all, purely through observation and social learning. That's not instinct. And it is worth flagging that this finding is over a decade old and stands entirely on its own, independent of the newer AI work, which is part of why it's such solid ground to build the rest of this story on. Line it up next to the newer acoustic data, and a picture starts to take shape, even if you set aside every overreaching headline attached to it. Crows appear to be maintaining a living, shared, constantly updated file on the humans in their territory. Some of that file is clearly about Risk, who has heard a crow who looks like someone who has. Some of it, based on the earliest patterns the AI has surfaced, may be much more mundane, closer to logistics. Who's on nest duty? Who just came home? Who's bringing food? And then there's the third piece of evidence, arguably the strangest one, which has nothing to do with the AI at all: what crows do when one of their own dies. Researchers have documented these gatherings, informally called crow funerals, for years, and Marsloff's follow-up work found something specific happens afterward. Crows that attended a gathering around a dead crow changed how they behaved around that location and around whatever circumstance was associated with the death. That's not grief in any sentimental sense, or at least not only that. It looks much more like an investigation, a way of pooling observation across a group to answer one practical question. What killed this bird? And is the threat still active? So where does that leave the version of this story racing around the internet, the one where AI has supposedly translated crow into human-named individuals and coordinated planning sessions? It leaves it ahead of the actual data, and the scientists doing the work are the first to say so. There's a real, meaningful gap between the model reliably sorts these calls into distinct categories, and the model decoded a name, and that gap is exactly where a viral clip and a peer-reviewed finding stop agreeing with each other. None of that undercuts what's actually confirmed, though. The neuron density is real. The threat-specific brain circuitry is real. The multi-generational transmission of a grudge against one specific human face is real, and it was documented years before any AI got involved. The behavioral shift after a crow funeral is real. What the AI adds isn't proof of language, at least not yet. It's scale, the ability to sift through a body of quiet, previously unlistenable recordings that no human team could ever get through by hand. Where that leads is still an open question, and the team in Spain is treating it that way, continuing to expand their call atlas with the stated goal of moving, eventually, from simple classification towards something closer to genuine comprehension of what individual calls are for. If they get there, some of the wilder claims circulating right now that crows assign names, coordinate plans, and pass regional warnings like a newswire might turn out to be less metaphor than most people currently assume. For now, though, the honest version of this story is smaller than the viral one, and it doesn't need the exaggeration to land. We already know, on evidence that isn't in dispute, that a crow can hold a grudge against a specific face for years, teach that grudge to offspring who never met the original threat, investigate its own dead, and change its behavior based on what it finds. Whether it can talk about any of that in detail is still being worked out, and the AI now combing through 150,000 recordings is the first serious attempt to find out.